I will say there's nothing quite like Don and Dale comedy first thing in the morning. I love it. So I've been with Autodesk for about 17 years. I've known this guy for way too many of those 17 years. Love this little company, by the way. I do want to say congratulations on 20 years. Fantastic. I don't know what the industry would do without you. So a big hand for these guys. So I have the best job in the world because I live in this kind of intersection between customers and product, innovation and technology. And I spend every day waking up thinking about these things, thinking about how we can kind of make the world a better place for our customers and our users and for the industry as a whole. And I want to talk a little bit about some of the challenges in the civil infrastructure industry and some of the things we're thinking about and working on that will help to transform that industry and really move things forward. So with that, this is an interesting little view of the world. There is actually $60 trillion in infrastructure funding needed by the year 2030. And this $36 trillion number is interesting because that's the amount that's unfunded. I could probably spend a half hour talking about funding and put you all to sleep, but that's probably not really a good thing. I'd be asleep too. What I would rather talk about is how we can use technology to provide better tools to put into the hands of users to really help to transform and bring these numbers down. That's probably more in my wheelhouse, to be honest. So one of the problems we have, and Don and Dale kind of specialize in this, is this concept of data silos. We have CAD data, GIS data, BIM data. We have ERP systems, EAM systems, and none of these systems are connected or work well together. This is actually a fairly large problem. Massive projects. So in the infrastructure space, these are some examples of very, very large projects. They affect a lot of lives. They cost a lot of money. And surprisingly, 60% of these projects actually fail to meet their cost targets in significant ways often. Another one, these projects' complexities are growing in many, many ways. There's large extended teams, they span continents, they're out in the field, they're in the office with all these data silos. It's almost impossible for these people to work effectively together. My favorite, however, is probably this one, which is that even in this day and age, when we go out and present a concept for a new project, it often looks like this. And I hear that statement far too many times. Imagine, if you will, and you have all of these people who really don't know how to read a design drawing or a paper map for that matter, and they're sitting there trying to understand how this new infrastructure project, maybe it's a highway interchange, is going to actually change and affect their life. Even worse, my favorite problem is if you miss the little blurb in the paper about the project that's going to happen in your neighborhood, you wake up the next day and you find out you've got a cell tower being constructed in your backyard. That's my favorite too. I think we can do better. So with that, I think there's a few transformative solutions. One of them being providing unified access to all of this federated data. And I'll use the words design and context quite a bit this morning because it's really about having rich contextual models and being able to design work and display those models in your designs within those large contextual models. So I'll talk a little bit about rich in context modeling and bringing analytics and simulation directly into that modeling environment. And then finally, I'll talk a little bit about kind of the concept of being able to access that anywhere, anytime, which is pretty critical, especially with that last slide that I just displayed. So what we really want is kind of an intelligent model-based process for the life cycle that is really fed by all of these federated data silos. And this is just for you, Dale. But is powered by kind of big data solutions and this notion of infinite compute. These are really large models. These are really large projects. You need to be able to aggregate all this information together. You need to be able to analyze all this information. And the cloud provides a lot of great solutions for providing infinite computing, which was, I think, coined by my CEO or CTO, to solve these problems. So this is a large contextual model of the city of LA. It contains GIS data, CAD data, some Revit models. This is underground LRT. So this model is being used for multiple projects in the city of LA by our customers. For Metro Line, what you'll notice as we go forward is this model is not just of LA, it's of all of Southern California. And you also see the high-speed rail project towards the tail end of this video extending out of LA towards its destination, which I believe is San Francisco, San Jose. Shows you what I know. I don't live in California. So this is the kind of thing that I'm talking about and the kind of data volumes I'm talking about. Now, GIS users are familiar with these data volumes all the time, but not in 3D. In 3D, you take all of that GIS data, all of that CAD data, all of that Revit data, put it into a 3D model, you get some incredible data volumes. Handling that efficiently is complex. There's another example. This is a little closer to home. This is the city of Edmonton. This model was used to, this is about a $2 billion project, LRT expansion in the city of Edmonton. So this is one of the stations above ground, below ground. Again, as we move forward, one of the things you'll see that we're also working to do is really bring LiDAR data and point clouds into this environment to further enrich the model. If you take a look at Autodesk, you'll see that we also invest heavily on a lot of LiDAR and point cloud 2 model-based solutions. Handling these really large data sets, that's a work in progress for us as well. And there's some of the LiDAR data in this model. Moving on a little bit. So this is my favorite question when I talk to a civil engineer, which is, that model is really, really cool. How'd you do that? Where do I start? So we've been tinkering with this little technology that allows our civil engineers who don't know how to spell GIS, select a little region on a map, and from that region in the map, we take the data in the cloud and we actually construct a model without them doing any work. With this model, they can start to do some conceptual planning, they can start to engineer some modifications to this environment, or they can take additional data sets and start to layer it into this environment to make it more rich. Honestly, with this technology, this was our #1 barrier to entry, was the fact that people just couldn't figure out how to get started because they didn't have the skill set that sits in this room. Another thing that we've been focused on is this idea of design in context. And road projects tend to be really big. They don't tend to be isolated. Rail projects are even bigger. And what we've tried to do is bring engineering directly into the 3D environment. So rather than force the user to go out, break the project up into 52,000 CAD files, engineer each segment, they can actually engineer in context, see how their design will actually impact both the environment and the existing context. And then they can do things like have some built-in analytics so that they can see various things that are happening with their design, like the fact that that tree is blocking turn, making it unsafe from a visibility point of view. We've taken this a step further and included bridge design. Drainage is also kind of a work in progress, but with bridge design, the thing is the intent here is not to provide a complete structural model of a bridge, but to give you a good contextual example of a bridge, to be able to engineer that bridge to a certain point so that you can take it out to a structural package and completely detail it. But what's great here is this is a real bridge model. It has a real parametric structure to it. I can manipulate it in context. You'll see these piers move. As you move the piers, the beams change. They get bigger or smaller. It really is a model that is ready to go out into more of a structural engineering package to be validated, further engineered, and eventually built. There's also full preliminary quantities on everything we do in the engineering space. So you get a good idea for, rough idea, let me put it that way, of how much your project will cost before you go into detail engineering. And that's simply not possible today. Moving on, analytics is an extremely important aspect of everything that we do. And what we really want to do is take those analytics, put them into very finite workflows that enable the design engineer or the problem solver to actually understand context and make the right decisions, to make informed decisions based on the data. And we want to do that directly in the 3D modeling environment. So bring all of these analytics results directly to the user in workflows that he understands that help him solve his problem. Another example that was kind of shown before is engineering analytics. And this is pretty important because in road projects, how often do you see a road project where you just think, what was that engineer thinking? Because I can't see around this corner. In Calgary, actually, they just built a new tower right along 9th Avenue. If you drive down 9th Avenue, if you drive down that road at the right time of day, you will be blinded by the sun. What were they thinking? So the whole idea here is to really provide tools to allow the designer to understand the safety of his road design in terms of anything that might be blocking visibility along turn, any kind of site visibility obstacles. We want to identify very early in the process, which is a huge cost saving later in the process, because once you've built that road, you really don't want to rebuild it. In this case, you can see the trees are actually blocking visibility in the turn. And if you move things a little bit, it all gets better. Moving on. Simulation is another kind of important aspect. We acquired this little technology last year, and we're still working on a complete integration. What I love about this technology is that not only does it simulate moving vehicles and understand vehicle interactions, it actually understands the entire commuter workflow. So if you need to leave your home in the morning, walk to the corner, catch a bus, take the bus to the train station, get on the train, take a train to work, walk across the street, get to the office, it actually understands those full interactions and can model those full interactions, which can help us not only simulate that in the model, but also make sure we deliver an optimal design based on transit times and time to commute, which is really important when you're talking about road projects, rail projects, things like that. Visualization. This is one of the places where Autodesk has invested heavily in the whole idea of infinite compute. We have a very high-end set of render nodes that can render models like this in the cloud very quickly, but not only can you render one, you can upload your model and render 500 shots, all kind of in parallel at the same time. Heavy investment in cloud computing really takes the time out of a lot of the tasks. Whole notion of infinite computing at work. This is a Dubai Metro station, by the way, planned project. I talked a little bit about anywhere, anytime access. This is another aspect of this. This is the city of San Francisco. And what you really want to be able to do is once you've created those designs, be able to put them out into the constituents' hands so they can understand how those designs are actually going to impact and affect their lives. We worked with a little company that actually took our designs, put them on an iPad, put them in a little device that looks like a viewfinder that you'd find on a mountaintop, probably find one right here in Vancouver somewhere. And the iPad was mounted in there, and they were placed along Market Street. And anybody who wanted to could walk up to these devices, look through it, and see what Market Street was going to look like when this redevelopment was done. In fact, there was 2 or 3 different options that they could look at through the viewfinder. So again, taking that design concept off of paper and putting it directly into the constituents' hands so they can understand how those projects are going to affect their lives and hopefully improve their lives. Also, you have an amazing number of field engineers that could use 3D context out in the field, including understanding what may be above ground, below ground, having access to all of the attribution, again, drawing from all of that federated data so that the asset management data is there at their fingertips, the ERP data is at their fingertips. Whatever they need to do their job in a very targeted workflow is basically at their fingertips. And we're working very hard to basically take these very large models, do a lot of pre-processing on them in the cloud using our infinite computing capabilities and put them into the hands of a field user. And then finally, this is one of my favorites. This is very recent. It was in the press very recently. We obviously have a close relationship with the city of San Francisco, but one of my favorite experiences in life over the years is I got to go to Shanghai, and we did this little, some of our engineers, we did this little field day where we went out and did a scavenger hunt through the city of Shanghai. That was an experience. But we went to the city museum that had a physical model of the city of Shanghai. At the time I was there, I think Shanghai had 18 million residents, and on any given day, there were 20 million people in the city of Shanghai. Literally, the model took up a whole floor of the building. You could walk above it, you could walk through it. It was a really cool thing. So Autodesk has been investing heavily in 3D printing. You might have seen that in the press. And we worked with some partners in the city of San Francisco to actually do a 3D print of, I think, 115 blocks in the city of San Francisco. Cool thing about this is every block is a separate object. They plug together like Lego. So if you want to update this thing, you take the pieces out and you replace the new ones. So this is San Francisco skyline in 2017. The other really cool thing that I'd never seen done before is they mounted projectors above the model so they could show thematics on a physical model. That was cool. And furthermore, they could overlay traffic patterns through these projectors. Never seen that before? I think it's a fantastic idea. And again, a way of taking that 2D model that we would typically see on a piece of paper, putting it into an environment where people can actually understand the change to their urban environment that is going to affect their lives in one way or another. And that is, I think, so going back, I should probably have a summary slide. So solutions that we're looking at, again, unified access to all this federated data, this notion of rich in-context modeling, analytics, and simulation right in that 3D model environment. Anywhere, anytime access, and the results, increased productivity, better decisions, optimized projects, and of course, reduce risk and much more predictable ROI for our customers, which means the cost of these projects can come down, the predictability can come down, and the ability to deliver these projects in the time frame they were intended to be delivered in becomes much more practical. Doesn't solve the funding problem, but certainly helps with the other challenges. With that, thank you very much.